Hello everyone, good morning. Good morning, good morning. So this is lecture number 8 of vector analysis. So if you haven't watched the previous videos, go through that. This is a continuation of the previous video, which is line integral, right? So in the previous class, we have solved some problems based on line integral. So I think we have solved almost, let me check that. So in the previous class, we have solved 7 problems based on line integral. So we'll continue solving problems based on line integrals, right? So this is the last video on line integral. The next class we will start surface integral, right? The next class we will start surface integral. Okay, so we'll continue solving problems. So this is a continuation of previous class. So you just recall all the formulas that is based on line integral. So they will give a vector f, vector field function. So you need to evaluate that over a curve. So it is nothing but integral over C f dot dr. Dr is dx I vector plus dy j vector plus dz k vector. Right? Okay. So we will do eighth problem now. Okay, so problem number 8. So evaluate integral over C e power minus x sin y dx plus cos y dy where C is the rectangle with vertices, with the vertices 0, 0, pi, 0, pi, pi by 2, sorry, it's 0, pi, pi by 2, 0, pi by 2, right? So we need to evaluate this integral. Again, very easy problem. In the previous class itself, we have solved one problem that is based on evaluating through a rectangle, right? Okay. So we need to evaluate this e power minus x sin y dx plus cos y dy. Okay. Now we'll just draw the diagram. Right. So these are y-axis and x-axis. Now the first vertices is 0, 0. So this is our first vertices 0, 0. This is 0, 0. Let us call this as A, B, C, D, right? 0, 0, and this is pi, 0, and this is pi, pi by 2, and this is 0, pi by 2, right? So we'll call this as A, B, C, D. So this is our A, this is our B, and this is our C, and this is our D. So we need to evaluate this F in this region, right? In this region. So this point is 0, 0. So this point is pi, 0, and this point is pi, pi by 2, and this point is 0, pi by 2, right? This point is 0, pi by 2. Okay, so we'll evaluate it. Let us break this into 4 parts. So I1, let's call this as I1, and call this as I2, and call this as I3, and call this as I4, right? So integral over C f dot dr. So for this problem, so integral over C f dot dr is nothing but integral over I1 plus integral over I2, that is integral over I1 f dot dr, right? So okay, let me write like that. So integral over I1 f dot dr plus integral over I2 f dot dr, integral over I3 f dot dr plus integral over I4 f dot dr. So if you haven't watched the previous class, go to that, right? Because the previous class itself we have given an introduction to line integral. So this is only problem solving in this class. Okay. So we will do one by one. So before that, what is integral over C f dot dr? This is nothing but integral over C. So e power minus x sin y integral over C. Okay, actually they have given f dot dr itself, right? Actually they have given they are given f dot dr itself. Usually they will give f to be a vector point function. So let us, that is like for example, they give f to be some x square I vector plus y square j vector. But here they are given f dot dr itself, right? Because you can see there is no ij, and also here we have dx and dy multiplied to each component. That means this is nothing but f dot dr, right? So the given integral is, this function is f dot dr, right? It is not f, it is not f, it is f dot dr. Okay. So they are given f dot dr directly, right? They are given f dot dr directly. So f dot dr is e power minus x sin y dx plus e power minus y cos y dx, right? I think you're getting my point. They are given f dot dr itself, right? Because f dot dr only, you will have something in dx plus something into dy. So if they give f means it should have ijk components, right? Okay. This is our f dot dr. So we will do one by one. So for I1, so you can see for I1, this is y is equal to 0 line, right? So y is equal to 0. So we have y is equal to 0. This implies dy is 0. And you can see x varies from 0 to pi, right? X varies from 0 to pi. That is, we are converting everything in terms of x. That means we need to vary x. So therefore, integral over I1 f dot dr is integral over x varies from 0 to pi e power minus y sin y dx plus e power minus x cos y dy, and we know dy is 0, so this term will be 0, and y is 0. So that means this will be again this will be 0, right? So if you put y is equal to 0, sin y is 0, so again this entire integral will be 0, right? So y is 0, dy is 0, so dy 0, this will be 0. If y is 0, sin y is 0, so therefore this integral will be fully vanished, right? This integral will be vanished. Now for I2, you can see this is a line x is equal to pi line, right? This is equal to pi line, and y varies from 0 to pi by 2. Here we have x is equal to pi. That means e is again 0 because pi is constant. So y varies from 0 to pi by 2. Y varies from 0 to pi by 2. Therefore, integral over I2 f dot dr will be y varies from 0 to pi by 2. So we are converting everything in terms of y. So we have e power minus y sin y dx plus e power minus x, sorry, this e power minus x, right? E power minus x, but no problem since this is 0, it is not going to affect us, right? So e power minus x sin y dx plus e power minus x cos y dy. So when x is equal to dx is 0, so therefore this term will be 0, and x is pi, right? So x is pi, therefore this will be y varies from 0 to pi e power minus pi into cos y dy. So e power minus pi is constant, so integration of cos y dy from 0 to pi, so this will be e power minus pi. So integration of cos y is sin y 0 to pi, so e power minus pi into again sin pi minus sin 0. So again this integral is 0, right? Because sin pi is 0, sin 0 is 0, so therefore I2 is also 0. Sorry, 0 to pi by 2, right? Sorry, 0 to pi by 2. Because pi varies from 0 to pi by 2, right? Sorry. So this will be sin pi by 2 minus sin 0. So we will have this to be equal to sin pi by 2 is 1, right? Sorry. So this will be e power minus pi into 1. So e power minus pi, right? E power minus pi is the value of the integral I2, right? Because you can see y varies from 0 to pi by 2. Sorry. Now we will find for I3 we will do. Now for I3 you can see what is this line? This line is y is equal to pi by 2 line, right? Y is equal to pi by 2 and x varies from pi to 0. Remember, direction is important. So y is equal to pi by 2. This implies dy is 0. X varies from pi to 0. X varies from pi to 0. Therefore, integral over I3 f dot dr will be x varies from pi to 0 e power minus x sin y dx plus e power minus x cos y dy. So dy is 0, so this term will be vanished. Y is equal to pi by 2. This will be pi to 0 e power minus x sin pi by 2 dx. So sin pi by 2 is 1, right? This is 1. So therefore, we will have integration of e power minus x dx pi to 0. It will be e power minus x divided by minus 1 pi to 0, right? So when you put upper and lower limit, so this will be minus. So upper limit is e power minus 0 minus e power minus pi. So this will be minus half. So e power 0 is 1 minus e power minus pi. So minus 1 plus e power minus pi is the value of I2, right? So integration of e power minus x is e power minus x by minus 1. So let's keep this minus outside. So upper limit minus lower limit. So e power 0 minus e power minus pi. So minus 1 plus e power minus pi is the value of I3. Now for I4, so for I4, x is equal to 0 line, right? This x is equal to 0. Y varies from pi by 2 to 0. X is equal to 0. This implies dx is 0. Y varies from pi by 2 to 0. So integration of I4 f dot dr will be y varies from pi by 2 to 0. So e power minus x sin y dx plus e power minus x cos y dy. So dx is 0, so therefore this term will be 0. And x is 0, so therefore e power 0 is 1. So we will have integration of cos y dy, right? This will be 1. E power 0 is 1. So y varies from pi by 2 to 0. So integration of cos y is sin y pi by 2 to 0. This will be sin 0 minus sin pi by 2. This will be minus 1, right? So therefore, integral over c f dot dr is integral over I1, integral over I2, integral over I3 plus integral over I4. So I1 value is 0 at I2. So I2 is e power minus pi. I3 is minus 1 plus e power minus pi, and I4 is minus 1, right? So this will be minus 2 times e power minus pi. Minus 1 minus 1. This is plus 2 times e power minus pi. So if I take this 2 outside, so minus 1 plus e power minus pi is the required answer. 2 times minus 1 minus e power minus pi is the required answer. Right? This is the required answer. Is it clear? Can you move on to the next problem? So this is UPSC question from 2015. Okay, so very easy problem. So move on to next problem. Problem number 9. We evaluate integral over f dot dr along the curve x square plus y square is equal to 1, z is equal to 1 in the positive direction from the positive direction from 0, 1, 1, 0, 1, 1 to 1 comma 0 comma 1, where f is 2x plus yz I vector plus xz j vector xy plus 2z k vector. Right? So we need to evaluate this over 0 comma 1 comma 1 to 1 comma 0 comma 1, right? Okay. Okay, so we do this solution. So we need to evaluate integral over c f dot dr along the curve x square plus y square is equal to 1, z is equal to 1 in the positive direction from 0 comma 1 comma 1 to 1 comma 0 comma 1, where f is okay. So first we will find f dot dr. So integral over c f dot dr is nothing but integral over c. So f dot dr will be 2x plus yz dx plus xz dy. You need to make a dot product with dr, right? So dr is dxi plus dyj plus tzk. So this will be xy plus 2z k vector, right? So 2x plus yz I vector, xz j vector, xy plus 2z k vector. Now we have z is equal to 1, right? So the curve is x square plus y square is equal to 1. That means y square will be 1 minus x square. So therefore y will be root of 1 minus x square, and z is always 1, right? And z is always 1. So therefore this will be integration of integral over c 2x plus y into z. So y is root of 1 minus x square into z is 1, right? Into z is 1 dx plus integration of, I'm just integrating separately, right? X into z. So x into z is 1, right? You just have to put these two values. Z is 1 and y is root of 1 minus x square into dy plus integration of x into y. So y is root of 1 minus x square plus 2z, right? Plus 2z. I think we have made a mistake. This will be integration of xz dy. Integration of, okay, wait. So if z is equal to 1, dz is 0, right? So we don't need this integral. Plus integral over c, this will be 0, right? So I'm just integrating separately. So integration of 2x plus, instead of y, I'm putting root of 1 minus x square into 1 dx, and integration of x into z is 1 and z is 1 and dz is 0. So therefore this will be 0 because dz is 0, right? Now what we will do is, here we have everything in terms of x, no problem, but here you can see x dy. So what we will do is we will shift x in terms of y. So we can easily do this, right? So x in terms of y. So x square is 1 minus y square. So x will be root of 1 minus y square. So y is root of 1 minus x square, or x is root of 1 minus x square. So this will be, so you can see everything is x. That means you need to vary x. So x varies from 0 to 1. So x varies from 0 to 1. 2x plus root of 1 minus x square dx. Here you can see I'm converting everything in terms of y, right? X into 1. So x is root of 1 minus y square into dy, and we are converting everything in terms of y. So y varies from 1 to 0. That's it, right? So you need to integrate this to get that. Very easy part, right? So you integrate this separately. So x varies from 0 to 1, 2x dx, integration of root of 1 minus x square 0 to 1 dx plus integration of y varies from 1 to 0 root of 1 minus y square dy, right? That's it, right? You need to integrate this. So integrate this, you will get the required answer. I think you need to use the formula integration of a square minus x square, right? I think I do this, right? So just have to use the formula integration of root of a square plus x square. So just write down the formula. So integration of root of a square minus x square, right? So just recall integration of root of a square minus x square dx, right? This is nothing but x by 2 root of a square minus x square plus a square by 2 sine inverse x by a, right? Just recall this. So apply that formula here, you'll get the answer. So therefore, this will be integration of 2 times, this is x square by 2, so 0 to 1 plus you just apply the formula root of a square minus x square. So a is 1 here, right? A is 1. So this will be x by 2 root of a square minus x square plus a square by 2. So that will be 1 by 2, right? That will be 1 by 2 sine inverse of x. Limit is 0 to 1. Here we have plus. Again, you apply the same formula here. So this will be y by 2 root of 1 minus y square plus 1 by 2 sine inverse of y by a. So a is 1, right? So x varies from 1 to 0. So this will be we will have 1 here, right? We will have 1 here. And what about sine inverse of 1? So sine inverse of 1 is sine will be 5 by 2. Okay. So here we will have, when you put upper limit, this will be 0 plus 1 by 2 sine inverse of 1. This will be upper limit minus lower limit will be 0, right? Because 0 into something is 0, sine inverse of 0 is 0. And similarly, we put upper limit. So upper limit is 0 minus lower limit. So lower limit is 0 plus 1 by 2 into sine inverse of 1. So this will be 1 plus 1 by 2 sine inverse of 1 is pi by 2. And here we will have minus 1 by 2 pi by 2. So these two will get cancelled. So we will have 1, right? So 1 is the required answer. So upper limit minus lower limit, right? So we just have to be careful that we have minus sign here. So therefore, so 1 is the required answer, right? So very easy problem. So they have given a curve x square plus y square is 1 and z is 1. So z is 1. So that means dz is 0. That means dz is 0. So we can easily cancel this part. So we will have only this. So you just convert y in terms of x in terms of y, and you just vary x limit and y limit. You will get the required answer, right? So very easy problem. Yes. So we will do next problem, 10th problem. So evaluate if f is equal to if f is equal to 3x square plus 6, 3x square plus 6y I vector minus 14yz j vector plus 20 xz square k vector. Then evaluate integral over C f dot dr from 0, 0, 0 to 1, 1, 1 along the curve x is equal to t, y is equal to t square, z is equal to t cube, right? So they have given the parametric equation of the curve, so you can use the parametric integral formula. That is, I have given the formula for line integral when it is in parametric form, right? Or else you can also do with this itself, right? What is integration of f dot dr? This is 3x square plus 6y dx plus integration of minus 14yz dy plus 20xz square dz, right? So we will convert everything in terms of t, right? We will convert everything in terms of t, and you can see t varies from 0 to 1, right? Because all are varying from 0 to 1. So we have x equal to t, that means dx by dt will be 1. Therefore dx is equal to dt, and we have y is equal to t square. So dy by dt is equal to 2t. So therefore dy will be 2t dt. Z is t cube. So dz by dt will be 3t square. So dz will be 3t square dt, right? And you replace x by t, y by t square, z by t cube. So everything will be converted in terms of t, and t varies from 0 to 1. So 3x square. So 3x square plus 6 times y. 6 times y. What is dx? Dx is dt. I'll do separately. So this will be t varies from 0 to 1 minus 14 times y into z. So y is t square, z is t cube. And what is dy? Dy is 2t dt plus integration of t varies from 0 to 1, 20 times x into z square. So x into z square, and what is tz? 3t square dt, right? T square dt. So from now on you can do, right? So this will be 9t square integration of 9t square 0 to 1 dt minus 4. I'll take this 14 to, so I'll take minus 28 outside. Integration of t varies from 0 to 1. So t power 5 into t. So t power 6 dt. T power 6 dt. So I'll take this 60 outside. T varies from 0 to 1. So t power 6. So t power 6, t power 8, t power 9. So this will be t power 9 dt, right? So you just integrate this. You just integrate this and get the required answers. So you'll get the answer to be equal to 5, right? So I'm not doing this. So if you do, you will have this to be t cube by 3. So upper limit minus lower limit minus 28 times t power 7 by 7. So upper limit minus lower limit plus 60 times upper limit minus lower limit. You will have this will be t power 10 by 10. So upper limit minus lower limit will be this. This will be 3. This will be 4. This will be 6, right? So minus 1 plus 6. So 5 is the required answer, right? So 5 is the required answer. So we move on to 11th problem. So find the total work done. Find the total work done in moving a particle in a force field F is equal to 3xy I vector minus 5z j vector plus 10x k vector along the curve x is equal to t square plus 1, y is equal to 2t square, z is equal to t cube, from t is equal to 1 to 2, right? So same as previous problem. The same as previous problem. So they're given the different curve and they're given t. So total work done is nothing but integral over c f dot dr, right? This will be integral over c 3xy dx minus 5z dy plus 10x into dz, right? So this is our integral over f dot dr. So we have x is equal to t square plus 1, y is equal to 2t cube, z is equal to t cube, right? Sorry, it is 2t square. So therefore, dx by dt will be 2t. So this implies dx is 2t dt. So dy by dt will be 4t. So dy is 4t dt. So dz by dt will be 3t square. Dz is 3t square dt, right? So we'll convert everything in terms of t now. So they are given t varies from 1 to 2. So 3 into x into y minus integration of 5 times z. So z is t cube. And what is dy? Sorry, here dx is 2t dt. Dx is 2t dt minus 5 times integration of z into dy. Z is t cube and dy is 4t dt, right? Plus 10 times integration of x is t square plus 1. Dz is 3t square dt, right? 3t square dt. Sorry, this is t cube. Right, so I'm just converting, I'm just using this, right? You just put x is equal to t square, y is equal to 2t square, z is equal to t cube plus 1. So x is t square plus 1, y is 2t square, z is t cube. So from now on you can easily do this, right? So I don't want to do that. It's a normal integration. So multiply this every term and then integrate this. So we'll get the answer to be 303. Very easy, right? So these are very easy. Just multiply this 4 outside. So minus 20. So integration of t power 4. So t power 5 by 5. So you will have you put upper limit to be equal to upper limit is 2, lower limit is 1. So integrate over that. You will get 303 is the required answer, right? We'll go to the next problem. So evaluate integral over c f dot dr where f is zi vector plus plus xj vector plus yk vector, where c is the arc of the curve, where c is the arc of the curve r of t, cos t I vector cos t I vector sin t j vector plus tk vector from t is equal to 0 to 2 pi. Very simple. So instead of x, y, z, so they have given x to be cos t, y to be sin t, z to be t, right? So we have x to be equal to cos t, y to be equal to sin t, because r of t, so it is x of t I vector, y of t j vector, z of t k vector. So z is t. So we need to vary from t varies from 0 to 2 pi. So dx by dt. So sin actually minus sin t. So therefore dx is minus sin t dt. And what about dy by dt? It is cos t. So therefore dy is cos t dt, and dz by dt is 1. Therefore dz is equal to dt. So integral over c f dot dr will be integral over t varies from 0 to 2 pi. F dot dr is z dx plus x dy plus y dz, right? So this will be integral over 0 to 2 pi. Z is t, dx is minus sin t dt, right? Plus integral over 0 to 2 pi x dy. So x is cos t, so dy is cos t dt, right? So x is cos t, z is t. Okay, this will be dy. So dy is cos t dt plus integral over 0 to 2 pi y dz. So y is sin t, dz is dt, right? So z is t, dx is minus sin t dt. Okay, so we need to integrate integral over 0 to 2 pi. We take this minus outside, t sin t plus integration of cos square t 0 to 2 pi dt plus integration of sin t dt 0 to 2 pi. Right? Now I think you can easily evaluate this. So you just apply uv method, integral u dv. This will be uv minus integral v du. So you take u to be equal to t, v to be equal to dv to be equal to sin t. So therefore du will be dt, v will be integration of sin t is minus cos t. So uv minus integral v du. You need to apply this formula here. And here, what is cos square t? It is 1 plus cos 2t by 2, right? So 1 plus cos 2t by 2 dt. And this is very easy, right? Integration of sin t dt 0 to 2 pi. So this will be minus of u into v. So u is t, v is minus cos t, limit is 0 to 1, 0 to 2 pi, minus integral v du. So v is minus cos t, du is dt, limit is 0 to 2 pi. And if I take this 1 by 2 outside, so integration of dt is t, integration of cos 2t is sin 2t by 2. So upper limit 0 to 2 pi, and integration of sin t is minus cos t 0 to 2 pi, right? So this will be minus, so upper limit minus lower limit. So upper limit, so we will have minus, okay, let us take this minus minus, okay, let us keep this as it is. So this will be upper limit is 2 pi into minus cos 2 pi minus lower limit, right? Because 0 into something is 0. And this will be plus integration of cos t is minus sin t 0 to 2 pi, right? So we'll have minus minus to be plus, integration of cos t is minus sin t dt. Okay. So here we will have 1 by 2. So upper limit minus lower limit. So upper limit is, right, just put t to be 2 pi. So 2 pi plus sin 4 pi by 2 minus lower limit will be 0, right? Because 0 plus sin 0 is 0. And here we will have cos 2 pi minus cos 0. So overall we are going to have, here we will have cos 2 pi will be cos 2 pi is 1, right? So cos n pi is minus 1 whole power n. So cos 2 pi will be, cos of even pi will be plus 1. when n is integer, so this will be 1, so we will have minus 2 pi, and here everything will be 0, right? Because sine 2 pi is 0, sine 0 is 0, plus 1 by 2, so here we will have 2 pi plus 0, again this is 0, so I'm just using this, right? So this will be 0, this will be 0, again this will be 0, because cos 2 pi is 1, cos 0 is 1, so again this will be 0, right? Both will be 1 minus 1, so we will have this to be equal to 2 pi plus pi, right? So 2 pi plus pi, yes, so 3 pi is the answer, right? So 3 pi is the required answer, right? So it is a normal integration that we come across in 11th 12th standard, right? So I'm using integration by parts. I'm using integration by parts. You need to integrate separately. So here, instead of giving x of t, y of t, z of t, they are given r, right? So that means you take this as x, you take this as y, you take this as z, and then given t varies from 0 to 2 pi, right? T varies from 0 to 2 pi. Is it clear? So evaluate integral over c f dot dr, where f is x, y, I vector, x square plus y square j vector, and c is the x-axis, and c is the x-axis from x is equal to 2 to 4, and the straight line x is equal to 4 from y is equal to 0 to 12, right? From very simple problem. So we just draw the diagram, then you will have more clarity. So what they given is, so we need to evaluate over f dot dr. So first from where c is the x-axis from 2 to 4. This is 2 and this is 4, right? So this will be 2 comma 0 and this point is 4 comma 0. So first we need to evaluate over this, right? And then the straight line x is equal to 4. The straight line x is equal to 4 is this from y is equal to 0 to 12. So that means this y is equal to 0 to 12. So that means from this is the line x is equal to 4. This will go on and on, but you can stop from 0 to 12. So that means this point is 12, this point is 0. So therefore this point will be 4 comma 12, right? This point is 4 comma 12. This point is 4 comma 0. That's it, right? So we need to evaluate over this. So you just do I1, I2, right? You just do I1 and I2, very simple. So for I1 you can see this is the line y is equal to 0 and this is the line x is equal to 4. So for I1 y is 0, x varies from 2 to 4, and for I2 x is equal to 4, y varies from 0 to 12. Or you can also do like, you just do this, right? You just do this and you find the equation of line joining these 2 points, that will also give you the same answer, right? You can do in 2 methods. You can find the equation of line joining these 2 points, evaluate that interval will be same as sum of these 2 integrals, right? Check with that. Okay, now I'll do with the usual method. For I1, okay, before that we will find integral over c f dot dr. So this will be integral over c x y dx x square plus y square dy. Now we will do separately. So for I1 y is 0, so that means dy is 0. X varies from 2 to 4, right? X varies from 2 to 4. So integral over I1 f dot dr will be x varies from 2 to 4 xy dx x square plus y square dy. So dy is 0 and we know y is also 0. So therefore this integral will be, full integral will be 0, right? Full integral will be 0. Okay. So for I2, you can see x is 4. That means dx is 0. Y varies from 0 to 12. So therefore, this will be integral of I2 f dot dr will be integral of y varies from 0 to 12. So f dot dr is xy dx x square plus y square dy. So dx is 0 and we know x is 4. So this will be integration of 16 plus y square dy, right? 16 plus y square dy. So 0 to 12. So normally integrate this. Right, so 16 into upper limit minus lower limit plus 1 by 3 12 cube, right? So 1 by 3 12 cube. So you just evaluate this. So this will be 192 and 12 cube by 3. So this will be 1 by 3 12 into 12 into 12. So this will be 4. So 12 12s are 144. So 144 into 4, right? So you will get this to be 570. Sorry, this will be 192. This will be, you will get this to be equal to 576. So the answer is 768. Okay, so 768 is the answer. Then everything is very easy problem. So we'll do one more, we'll do 2 to 3 problems and then we'll wind off. We'll do some more problems. So I'll give some exercise problem now. So the 14th problem is exercise problem. So evaluate integral over C f dot dr where f is xy I vector plus the same f x square plus y square j vector, and C is the rectangle in the xy plane bounded by the lines x is equal to 2, y is equal to 2, x is equal to 4, y is equal to 10, x is equal to 1, right? So you just need to do the problem. So the answer will be okay. I don't know the answer, so you just comment the answer. If more than 2 to 3% comment the same answer, that will be the answer, right? Okay. So I'll just give you the diagram for this. So you can see y is 2. So y is 2 means this is the line y is equal to 2. And we have y is equal to 10. Okay, let us call this as y is equal to 10. And y is equal to 2. So this is the line y is equal to 2. So this point is 2. And this point is 10. X is equal to 1. So x is equal to 1 will be somewhere around here. This x is equal to 1, x is equal to 4, right? So this is 4. So you just have to evaluate this over this rectangle, right? So this is the rectangle you need. Now you can do this, right? This is called this as A, B, C, D. So this point is 1, 2, right? This point is 1, 2, and this point is 4, 2. This point is P, and this point is 4, 10, and this point is 1, 10, right? So you do this as I1, this is I2, this is I3, and this is I4. So I given you the lot of int, right? You just have to, we have did many problems based on this. So for I1, what is this line? For I1, y is equal to 2, x varies from 1 to 4. For I2, you take the line x is equal to 4, and you vary y to be from 2 to 10. And for I3, y is equal to 10, and for this, x is equal to 1. Right? We have did many problems based on this. So you just have to evaluate this integral, right? So I think I have covered almost all problems on line integral. Okay, here you will get answer to be equal to 60. You will get answer to be equal to 60. 15th problem. So evaluate, so find the circulation of a around the curve. Find the circulation of F around the curve. Find the circulation of F around the curve where F is 2x plus y square I vector plus 3y minus 4x j vector, and C is the curve y is equal to x square, and C is the curve y is equal to x square from 0, 0 to 1, 1, and the curve y square is equal to x from 1, 1 to 0, 0. It's a very simple problem. So we already did so much of problem like this, right, in the very beginning part. So find the circulation of the F around the curve. So actually here we have two curves, right? So integration over Cf dot dr will be integral over C1 f dot dr plus integral over C2 f dot dr. So C1 is this curve. So C1 is this curve, and C2 is this curve. So find C1 and C2 and add it up, right? So diagram will be like, y is equal to x square. So y is equal to x square. So this is from 0, 0 to 1, 1, right? From 0, 0 to 1, 1, and then y square is equal to x. This is same as x is equal to y square. So x is equal to y square is open upward parabola, right? Open upward parabola, yes. So you will have something like this, right? Okay, let me draw the diagram more easy. So y is equal to x square is, sorry, this is open rightward parabola. So it will be like this, right? So this is the this point is 1, 1. So this is the curve y is equal to x square, right? So call this as C1, and this is the curve y is equal to x square. So y is equal to x square is rightward, and we have y square is equal to x. That is same as x is equal to y square, which is open upward parabola. So we will have something like this, right? So this is our y is equal to x square. This is our C1. Let us call this as C1 and call this as C2. So C1 is from 0, 0 to 1, 1, and the curve y square is equal to x. This is the curve y square is equal to x from 1, 1 to 0, 0. So you can see I'm using this arrow mark, right? I'm using this arrow mark. So C1, C2. So C1 is this is the curve, right? So y is equal to x square, and C2 is x is equal to y square, and from here the direction is here, right? Okay, wait. Y is equal to x square, right? Okay, sorry. This is upward, so that means this is the C1, right? Sorry. This is C1, so which is x square is equal to y, and this is y square is equal to x, which is an open rightward parabola. This is x is equal to y square. Sorry, right? So x square is open upward, and y square is equal to something means this is rightward. Okay, sorry. So we need to evaluate this over this. Now we can easily do this, right? So for C1, I think you can do it from your own, right? You can do from your own. This is clear, right? This is upward parabola. This is upward parabola. That means x square is equal to something. And this is rightward parabola. That means y square is equal to something, right? Okay, clear. So for C1, you can see y is equal to x square. So that means I'm converting everything in terms of x now. So that means dy will be 2x dx. X varies from 0 to 1, right? This point is 1, 0. So x varies from 0 to 1. Therefore, integral over C1 f dot dr will be x varies from 0 to 1, 2x plus y square dx. Yes, you can do it. You can do this, right? Okay, sure. So I'm just going to give the answer only, because we have did so much of problem like this, right? So integral over 3y minus 4x dy. So you just put y to be equal to x square, and you put dy to be equal to 2x dx. So you will have everything in terms of x, integrate over it, right? You'll get the answer. Okay, you can do this, right? Okay. And for I2, for C2, you can see x I'm converting everything in terms of x now, right? Everything in terms of y now. So x varies from, you can also convert y to be in terms of x by putting y to be equal to root x also, right? It will take time. So x is equal to y square. So dx will be 2y dy. So everything in terms of y. So y varies from this. We are coming in this direction, right? 1 to 0. So y varies from 1 to 0. Right? I think you do this, right? So you just convert everything in terms of y. You just find integral over f dot dr. So y varies from 1 to 0. So 2x plus y square dx plus 3y minus 4x dy. So if you are converting everything in terms of y, so you replace x to be equal to y square, x to be equal to y square, and dy to be 2y dy. So we will have everything in terms of y. Dy is dy, dx is 2y dy. So dx is 2y dy. Let's keep this as this. So after doing this, you convert x to be equal to y square, x to be equal to y square. So we will have everything in terms of y. So find C2. So the answer we're going to get is, minus 49 by 30. Right? Minus 49 by 30 is the required answer. So we have did so much of problem like this, right? So that is why I'm just leaving some. I'm leaving this as exercise because the first 4 to 5 problems is purely based on this, right? They will give a curve from they will give the endpoints also. So for C1, y is equal to x square. X varies from 0 to 1, and for C2, x is equal to y square and y varies from 1 to 0. So here you convert everything in terms of x. So you just replace y to be equal to x square, y to be equal to x square, and we know dy is 2x dx. So you will have everything in terms of x here, right? This will be x power 4 because y is square. So you will have everything in terms of x. So integrate over 0 to 1 and add it up. Overall, you're going to get minus 49/30 as the required answer, right? So I think I have covered almost many problems on line integral. So if you want, I can also give you some more problems on line integral. Okay, I'll give one more problem, 16th problem. So evaluate okay, so I think I do this problem, right? Because I haven't done problem based on triangle yet. So we'll do a problem based on triangle and then I'll wind up. So if f is equal to 2x square plus y square I vector 3y minus 4x j vector, evaluate integral over C f dot dr around the triangle ABC. So we haven't done triangle problem, right? Okay. Whose vertices are very simple again. Whose vertices are, so A is 0, 0, B is 2, 0, C is 2, 1, right? So very simple problem. So don't get panic by looking at the question, right? Very simple problem. So we need to evaluate this over f dot dr over a triangle. So this point is 0, 0, this point is 2, 0, and this point is 2, 1. So we will have this to be equal to, so this is I1, I2, I3, right? So this is I1, I2, and this is I3, and this point is 0, 0, and this point is 2, 0, and this point is 2, 1, right? I1, I2 is very easy. For I3, you need to find equation of line joining these 2 points, right? So for I1, before that, what is integral f dot dr? So it is 2x square plus y square dx plus 3y minus 4x dy, right? Now we'll do one by one. For I1, we have y is equal to 0. That means dy is 0. X varies from 0 to 2, right? X varies from 0 to 2. Therefore, integral over I1 f dot dr will be x varies from 0 to 2. 2x square plus y square dx plus 3y minus 4x dy. So dy is 0 and we know y is also 0. So we will have 2 times integration of x square dx. So 2 times x cube by 3, 0 to 2. So 2 by 3, 2 cube is 8. So this will be 16 by 3. So I1 is 16 by 3, right? So y is 0, this term will be 0, this term full will be 0. So 2x square dx will be 2 times x cube by 3, so 0 to 2. So I1 is 16 by 3. Similarly for I2, we have, what is this line? This line is x equal to 2 line, right? So for I2, x is equal to 2, dx is 0. So y varies from 0 to 1. Y varies from 0 to 1. Therefore, integral over I2 f dot dr will be integral over I2. So f dot dr is 2x square plus y square dx plus 3y minus 4x dy. So dx is 0. So this term will be 0. X is 2. So x is 2. Y varies from 0 to 1. So 3y minus 4 into 2 dy, right? Because this x is 2, this x is 2. So integrate over it. So 3 times integration of y dy is y squared by 2, 0 to 1. Minus 8 is constant, 0 to 1. So this will be so this will be 3 by 2 minus 8. So this will be 3 minus 16 by 2. So minus 13 by 2, right? Minus 13 by 2. Okay, so yes, actually Saturday we have a test on divergence, sorry, gradient divergence curve. So I will update that tomorrow. So Saturday night I will send the question paper. Saturday evening 6 o'clock I will send the question paper. You can send the answer sheet by next day morning 11 a.m. right? So I will send the question paper on Saturday 6 p.m. You can take any 3 hours between Saturday 6 p.m. to Sunday 11 a.m. You will write it and take a PDF of it and send that. I'll send the procedure later. So this will be minus 13 by 2, right? So this will be minus 13 by 2. Now for I3, so for I3 you need to find equation of line joining 2 points, right? So what is the equation of this line? So we need to find equation of line joining 2 comma 1 and 0 comma 0. This will be y minus y1 is equal to m into x minus x1. So this is x1 y1, this is x2 y2. So y minus y1 m into x minus x1. So what is m? M is the slope y2 minus y1 divided by x2 minus x1. X2 minus x1. So y2 minus y1 divided by x2 minus x1. So minus 1 by 2. This is plus 1 by 2. This is plus 1 by 2. So cross multiply this. So we have 2y minus 2 is equal to x minus 2. So 2y is equal to x, right? Y is equal to x by 2, right? Y is 2x or x by 2? X is equal to 2y, right? Yes, okay. So we have 2y is equal to x. So therefore, integral over c, f dot dr will be integral over c. So f dot dr is 2x square plus y square dx plus 3y minus 4x dy, right? So what we can do is we will convert everything in terms of, we will convert x in terms of y, right? Because if we convert y in terms of x, we will have some fraction. We will convert x in terms of y. That is, we are converting everything in terms of y. That means you need to vary y. So y varies from 1 to 0. Right? If you want to put y to be equal to x by 2, then you can convert everything in terms of x. So therefore, 1 minute. Yes, okay. So you can see y varies from 1 to 0. So this will be integration of y varies from 1 to 0. X is 2y, right? So I think I do this, right? So x is 2y. So what about dx? dx is 2 dy. So you do this, right? So overall you're going to get answer to be, that is if you add I1, I2, I3, so overall you're going to get answer to be equal to minus 14 by 3, right? This is overall answer, right? So you'll get this answer separately. You just add it up, I1, I2, I3. You will get the overall answer to be equal to minus 14 by 3, right? So if you want some more problem, I'll give some more problem also for practice in Telegram group. But I have covered almost all types of problems based on line integral. So if you have some more problems, you can also do it later, right? So next class, we're going to start surface integral. So we'll see in the next class, right? So thank you.